HOMED's overarching goal is to develop a comprehensive panel of scientific knowledge and practical solutions for the management of emerging native and non-native pests and pathogens, or PNPs, threatening European forests. This comprehensive panel must consider the full pathway of PNP's invasion management, from assessment to control. An important step in this process is the creation of tools for rapid early detection, which allows stakeholders to stop an invasion before it even starts. In this context, the HOMED project presents two traps which support the trapping and surveillance of forest pests in high-risk sites, such as international commercial ports. The first tool is the multi-lure generic beetle trap developed by a team of researchers at the French National Research Institute for Agriculture, Food and the Environment, or INRAE. By targeting multiple species of diverse taxa simultaneously, this prototype could help anticipate a wider range of unregulated species and to limit costs with a reduced number of traps within each site.
I am Alain Roch from INRAE, also a member of the HOMED project. So we are facing now a problem with the invasive insects. Most of them who arrived during the last 50 years were unknown species that were not listed in the quarantine lists. And so the idea was to develop some kind of generic tool that can trap a number of these unknown species when they arrive. I mean, when they arrive at the ports of entry, for instance, ports, harbor, airports, or other kind of places where they can arrive in a continent. So, based on recent progress in the chemical ecology of longhorn beetle, which is an important group of invader, we propose to use a blend of 10 pheromones of these longhorn beetles that can cover a large scope of attraction and so trap these insects when they are arriving. You can see here a trap which is put here in a forest just near the port of Bayonne. We put black and green trap because the different species are attracted by different colors in order to trap the insect when they arrive, and trap just outside the port in the very close environment in order to understand if the species disperse or not. So here you have the compounds which correspond to 1 milliliter of a blend of pheromones on a dental cotton, and this is attracting the insects for a period of 3 weeks. We added ethanol and alpha-pinene that are plant volatiles that can attract bark beetles, ambrosia beetles, but also that can have a synergy for the longhorn beetles. One thing that is important is that such a trapping program has been developed under the HOMED project worldwide, in China, in the US, in Canada, in Australia, so that we know the species that have been trapped in this continent, and we can warn people here about the possibility of trapping them when they arrive in Europe. Another important point I want to mention is that it was at first an experimental project. Now it is a routine protocol used by the French Ministry of Agriculture that has been deployed in 16 ports of France in order to trap the insects that are arriving in these ports.
The second tool is a light trap for containers developed by the University of Padova. It is a simple yet ingenious trap prototype which is easily manageable and aims at detecting insect alien species inside shipping containers during cargo travel. The idea is to put these light traps inside shipping containers to trap insects during cargo travel, thus preventing the release of quarantine pests.
Hi, I'm Andrea Battisti from the Padova University in Italy, and I'm a partner of the HOMED project, and I would present a small product that we have developed within the project, starting from the commercial available product which is called Trans Trap. Ideally, it is a trap to be deployed on a container, on a cargo container, for trapping insects that could emerge from the commodities that are transported inside the container. So the idea is that the trap will be open inside the container is very dark, and there's a tiny LED light in the middle which is working with the batteries here, and the light will attract flying insects that are released by the commodities taken inside the container. So whenever the container is arrived at the destination port, the box will be taken by the inspector and any type of item that could be trapped, any type of insect, will be counted and assessed. The problem is that how to easily identify insects that are trapped inside the container, and that will be the next step of our research. Because ideally what we want to propose is that every container will be transporting one trap, and so the facilities will be available for inspectors to say whether dangerous or harmful insects are taken with the commodities during the travel of the container.
The use of such a simple device could be widely spread to all shipping companies ruled by an international agreement for global insect flow surveillance. Additionally, a routine control protocol could be set up between container managers, inspectors, and entomologists using this trap, or by pursuing its development with image analysis through artificial intelligence and deep learning for real-time insect identification. With increasing global trade and such a large volume of commodities transported in containers all around the world, even minimal percentages of container contamination can represent a serious risk of introductions of new alien pests. In this respect, these tools could be an effective way to improve the early detection of alien species at points of entry and prevent new invasions.